Hello, everybody. Welcome to today's Cloud Lunch and Learn session. I am your moderator today, Dwayne Natwick, Microsoft certified trainer and Microsoft MVP. Welcome. I apologize for being a little bit late. I was finishing up a class and going to lunch, so it's completely my fault. But with us today, we have Manas Sharma, and he is going to talk about combating AI voice spoofing and how to do real-time detection of ransomware scam calls. So looking forward to hearing about this. So I will turn things over to you, Manas, and have a great session.
Awesome. Thanks for having me, Dwayne. I appreciate it. My name is Manas. I'm an engineer at Google. I work on BigQuery. My background has been in database internals, but on the side, me and my friends, we've been kind of diving into the AI landscape. We strongly feel that, uh, you know, in the realm of security and threat detection, the industry will see a dramatic shifts as and when AI models and uh, just are getting better. We need better detection mechanisms as well. And just to give some background, we started working on this problem about 2 years ago when someone very close to my friend was actually spoofed. There was a social engineering attempt, and someone impersonated their closed one, and they were able to extract out a significant amount of money from them. So it came to our attention that as engineers, we should start looking into solutions to this problem. It's only going to get worse and worse. So yeah, I just wanted to have this conversation, see the work that show you the work that we have done, and also just paint the landscape of how things are evolving in this space. Uh, yeah, since we started working on this problem, there has been a paradigm shift because GPT 4.5 has passed the Turing test. So our threat detection models and everything needs to continue to evolve to catch up with the advancements in generative AI. So to just give you some background, I was looking into. We'll start with the slides momentarily, but just to show you how things have progressed, I've shared my screen. I was looking at this website called voice.ai, and it lets you mask your voice over to any celebrity's voice for free. It's available to anyone. Uh, you can you can actually convert a certain number of voices for free. But just to paint a picture, if a website like this is publicly available, uh, all this is not sci-fi. You can It's not that hard for malicious agents to uh, take a voice sample and generate a model out of it and just do malicious stuff. And also, I was looking at Spotify, and there's this new channel where these uh, there's someone who's impersonating Joe Rogan. It's an AI version of Joe Rogan, and he interviews uh, people from the past and celebrities who otherwise he won't have access to. So these are AI agents talking to AI agents, and you can literally not make out if it's really a real person or someone who's simulated having the conversation. So uh, just to paint the landscape that things are evolving really fast. Before we get into the presentation, I also wanted to share some numbers. Um, so there has been an exponential growth when it comes to AI generated spoofing scams. If you see, the graph is not linear. It was kind of linear until 2022, but since the advent of generative AI and the more advanced models, we've seen an exponential growth in AI voice spoofing scams. And just to give some recent examples, there was this Arup engineering scam where someone impersonated the CEO of Arup Engineering. And by using deepfakes and voice modulation, they were able to dupe the firm of $25 million. It's very recent. A UK energy company, there was a 243K scam where someone again impersonated being a high-ranking official, and they were able to dupe their they were able to dupe the team to transfer a large sum of money by the virtue of this. UAE, there was again a corporate director scam of 51 million, again involving voice cloning, financial fraud, and family emergency scams have been pretty much on the rise, especially in India, where I come from. I continuously see uh, people of the older generation being victims of social engineering and voice modulation scams, where someone impersonates their loved ones in distress, asks a large sum of money to be transferred, and people are duped that way. So how this generally is taken care, how this generally is handled is by the virtue of voice harvesting. And since the models are getting more and more advanced, you don't need a whole lot of voice samples to generate to basically create synthetic versions of people talking. You actually just need samples of 3 to 30 seconds. uh, and by I mean, a lot of people now have social media presence, so they nonchalantly post videos of themselves talking online, either on YouTube or other social media platforms like TikTok. And it's not hard for malicious users to take a particular voice sample and then use that against you. So that aspect of social engineering will always be there, where people have to be educated that even though tech is evolving and detection mechanisms will continue to evolve, but the social engineering side of it will always be there. So yeah, AI generation, the generative adversarial networks, they're getting more and more advanced. Also, diffusion models now just require 3 to 30 seconds of voice samples to create replicas. Uh, and yeah, the live modulation, which is more recent, happens near real time, where the voice sample is masked to create replicas. uh, so this is just more advanced form of social engineering with very hard to detect replicas now. uh, and why I wanted to bring this up to this platform, because it's the platform is specifically for the target audience is cloud engineers and people well versed with cloud technologies. uh, these AI models, they require a significant hardware to run, and while we want to have detection on the client side, the computation and running the models will likely require cloud infrastructure to run the hardware and sort of do the computation at the back end, and then just return a boolean, whether a voice is actually a replica or a spoofed voice to the client side. So, solid cloud architecture is definitely required to solve this particular problem. Uh, and this is just a sample. This is a sample architecture that I was actually working on. There's a toy application that me and my friend built. This is pre GPT 4.5, where again we deployed our models on cloud infrastructure. The client was pretty lightweight. We were streaming uh, voice signals received and running them on the cloud and returning results to the user. So solid cloud infrastructure will always be required to run these kind of models to detect spoofs. Okay, so with that out of the way, the background in place and the threat landscape, uh, I can now move to the slides. Uh, Let me switch context here. So yeah, thanks for sharing the slides, Wayne. Uh, I already painted the picture for this. This is an evolving space. Generative models are passing Turing tests, so it becomes more and more pertinent that we as IT professionals and software engineers try to find solutions to detect such spoofs and ransomware calls, because malicious actors are targeting weaker sections to basically their advantage. So we have to be at the top of this. Uh, Next slide, please. Okay. Yeah, we spoke about the market growth, how these AI scams are not growing at a linear rate anymore. And with the advancement in AI, it's becoming harder and harder for people to self-identify uh, what is a replica versus what is not a replica. Uh, and there is, of course, sophisticated targeting where, at least in the research that we did, people who are, I mean, the senior citizens are essentially being targeted more than the younger population, because maybe they don't have exposure to AI. So, with a combination of social engineering and advancement in AI, this is becoming a serious threat. And yeah, so the modern countermeasures, they involve convoluted neural networks extracting acoustic fingerprints and identifying temporal anomalies in speech patterns. What does this mean? So basically, a voice signal is taken, it's amplified, and it's converted into a sine wave essentially. And we try to the classification at the very bare bones is basically. If you train the model with a certain corpus of AI generated voice samples and their sine waves, and then in near real time, a voice signal is converted to that sine wave, and we try to do an overlap and see if this is actually a real human speaking versus an AI generated voice sample. Uh, and of course, this is much more sophisticated. At least the versions which are recently in the market, they run classifications against a lot of parameters. Uh, this slide talks about 500 parameters, but this is evolving. Uh, and the parameters include things like punctuations, whether uh, humans, when they talk, they have a certain amount of punctuations and variation in speech, versus what we've seen as AI, the generated voice samples, they tend to be smoother. Uh, so we have to classify against a lot of parameters. Okay, so how does AI voice modulation works? Uh, like we discussed in the previous document, with the advancement in generative adversarial networks, these malicious actors can create replicas of your voice just by having a handle on samples which are 3 to 30 seconds long. So social media serves as a large corpus where they fish for people who post videos and stuff like that on public platforms, use that as a training sample, and then generate uh, simulated versions of the person. Uh, and emotional tones are also manipulated in real time. So uh, we have to have a combination of not only recognizing spectral analysis, but also having context that, hey, if you receive a call which shows a certain spectral analysis uh, fingerprint, and the context is around a distress call or some sort of social engineering, then the likelihood of that being a scam call is super high. So the detection mechanism needs a bunch of classifiers, not just a singular classifier. So yeah, identifying compression artifacts in the synthetic speech. So AI has a uh, at higher frequencies, if you do spectral analysis, AI shows a lot of smoothness in their processed waves, as opposed to humans. So at higher frequencies, we can do classification there, and the behavioral inconsistencies. Like I said, humans have a certain amount of punctuations and pauses in speech, which AI doesn't. So we have to be able to train our classifiers to look for these subtle hints and signatures. Okay, so the detection mechanism is fourfold, at least uh, in the toy that we had developed. Firstly, audio signal processing. This is where the spectral analysis comes in, where a voice sample is taken near real time, it's amplified, and the spectral analysis is carried out where the wave that we match a wave against a corpus of pre-trained waves and see if there's any match there. By the virtue of acoustic fingerprinting, I mean, each generative model has a certain fingerprint. uh, so we can do a match, the fingerprint with the corpus. So this can be twofold, actually: fingerprinting against uh, already known AI models, uh, and see if there is any if there's a high match with the fingerprint of any existing model. Then we can essentially say that there's a high chance that the voice sample is of a AI model. Neural network classification, of course. Deep learning models on real AI generated sample have pretty high accuracy, and long term, short term architecture is leveraged to identify inconsistencies in synthetic speech. An ensemble detection, basically, we combine multiple classification techniques to reduce the likelihood of false positives. Now, so yeah, just to recap: audio signal processing, we take a voice signal, we do a Fourier transform on top of that, and then we try to classify this against pre-trained data to identify if there's any likelihood of this being coming from a spoof or a replica. Fingerprinting is, again, we basically have a corpus of pre-training. We have a corpus of AI model and their subtleties when it comes to speech generation, and we basically try to match whether the voice sample, which is currently in contention, has a fingerprint that is closely matching with our corpus, uh, so on and so forth. Yeah, so the stream processing generally happens at higher frequencies, because it's at higher frequencies, non-audible frequencies, where we see variance and easy to detect attributes between uh, generated samples versus real human samples. Uh, Spectral analysis, or something we've already spoken about, where we take a voice sample, convert it, do a Fourier transformation on that, and then try to match it with uh, a corpus of existing trained data. Okay, and we discussed how this will require cloud architecture, because on any thin clients running models, there's not enough computation available. There's not enough compute capacity available on thin clients to do detection. So solid cloud architectures will be required, essentially, to stream data from the client over to your servers, where the models will be deployed, and uh, the classification will happen. So we definitely need a pretty solid cloud infrastructure and architecture to uh, do classification on real-time voice modulation scams. Okay, watermark recognition. Digital watermarking identifies signatures from responsible AI voice generators using frequency domain analysis. Okay, so like we said, every other generative AI model has some intricacies in the corpus it generates. So by the virtue of digital watermarking, we can overlay a sample with what we have in our corpus and see if it is actually if any AI agent was used to generate the sample. Uh, but again, watermarking slash cataloging is something that needs to continue to evolve because models are continuing to evolve. There are bug fixes and advancements taking place, so uh, we cannot have a static corpus. We have to continue updating our corpus as these models are getting more and more advanced. Imperceptible markers. So imperceptible markers will be again attributes of uh, human speech, like pauses and some acoustic patterns, essentially. This is harder to work with because of the various attributes and facets. Uh, Cross-reference databases maintains responsibility of known AI signatures using federated learning to update decision models without compromising confidentiality. Again, this is just talking about having a corpus of pre-trained models and just doing a hard check to see if the sample in contention matches with what we've already seen in the past. Okay, so behavioral analysis, we already talk about doing spectral analysis where we would take a voice signal, amplify it, try to see subtle markers which would identify AI generated stuff from human or non AI stuff. But behavioral analysis is where we have an edge. So humans have a particular behavioral pattern when they talk. Uh, for instance, breathe patterns, subtle pauses, stress variations, which AI doesn't have. So we have to use a we in our example relied on CNNs to identify behavioral anomalies in AI generated corpus. Uh, but this is again a evolving space. Uh, Humans also have anomalies in timing. So AI generated stuff is pretty smooth. So there's a way for us to uh, catch or classify uh, AI generated stuff in with regards to timing anomalies. Uh, Yeah, so we continue talking about humans have some subconscious vocal artifacts like throat clearing or clicking. And generally, even advanced AI models, they don't have such emotional coherence attributes in the stuff that they generate. So, with the leverage on behavioral analytics, the classification accuracy goes significantly up if we can if we can add more and more dimensions to behavioral analysis. uh, a stronger true positive detection, definitely, I mean, the rate of that significantly goes up. So uh, this is primarily where we have room to play with behavioral analysis when it comes to detecting AI generated corpus. So the following slides just talk about the implementation that me and my friend did. It was kind of like a toy application. We also wrote a paper on this on our implementation. So I'll share the paper with uh, the audience so you can read more about our implementation. And uh, this is from 2 years ago. So yeah, I'll share. Again, this talks about a lightweight client which streams data to the backend, where we have beefier hardware to do uh, classification, feature extraction, those kind of fun stuff. These numbers are just again from our toy application and experiments. Yeah, so the real-time integration is pretty important, and in our application, we basically had a client-side daemon running and basically doing voice sample extractions when either a simple voice call was made. So there was a daemon always running, capturing voice samples, sending it upstream to our cloud deployed application, and running classified models on top of that. So this needs to be always running. Listen to various voice sources like WhatsApp or voice over internet calls, and stream data to cloud. Uh, so there's obviously a bandwidth and network cost associated to it. We try to keep the client side application very lightweight on memory, uh, but still there's a memory footprint associated with the client side application. Okay, so just to get wrap on this, the threat landscape of AI voice spoofing is growing. From the graphs that I shared previously with you, uh, the trend is not linear anymore; it's exponential. And more recently, Arup Engineering and a UK-based energy firm were duped of millions of dollars actually, and we're talking about people who are pretty smart, and uh, they were duped by malicious actors. So the more the concern to step up and build solutions around this to guard uh, other strata of society which may not be well versed with technology. Uh, the detection application that me and my colleague worked was a multi-layered detection. Had a multi-layered detection architecture where we did spectral analysis, behavioral analysis, fingerprinting, uh, to finally classify whether a voice sample was humans or synthetic. Uh, and going forward, I truly believe that we will need multi-layered detection approaches because AI models are getting more and more advanced. Uh, so we talked about practical implementation where the client side needs to be really lean, while your detection, the models which will do the detection will be hosted in cloud infrastructure, and that's where all the classification and the heavy lifting will take place. Uh, yeah, so this this architecture should should be deployable across a variety of uh, clients, cell phones, and even smartwatches, for instance, because people take calls on smartwatches as well. So tablets, mobile phones, and smartwatches, they can all have a lightweight client which will stream these voice samples to cloud infrastructure where we will do the sampling. So that's it. Thank you. You're on mute. Sorry.
Yeah, thank you, Manas. I appreciate the information. I've done a lot of talks myself around deep fakes and things. So yeah, so some of these aspects of how easily and quickly we can somebody can spoof our voice and likeness is becoming more and more the norm rather than the exception. So I appreciate you sharing that with everybody here today. Hopefully everybody enjoyed this session, whether you're watching it live right now or whether you're watching it on the Cloud Lunch and Learn YouTube channel later on. Thank you very much for taking your time in us and providing this great presentation. So thanks everybody for joining Cloud Lunch and Learn. Keep up on the Cloud Lunch Learn lunchlearn.com for upcoming sessions. So other than that, thanks everybody and have a great rest of your day.
Thank you. Bye bye, Nate.